Hello, everybody. This is Mrs. Pound. I am back with another chapter, Chapter 2, about matter from BJU Chemistry's 5th edition. So, the first thing I want to talk about in section 2.1 is the classification of matter, and this video is broken up into two parts. Our objective for this video is to compare physical and chemical properties. First, we'll talk about what a physical property is, and that is any property of matter that can be measured or observed without changing the actual composition of the material. So, one common physical property is density. This is the amount of matter packed into a given volume. And as I have a picture of a lot of houses packed together in a small area. So, this is very densely packed, and it's in a city, so densely packed. Where if it was in the suburbs, it wouldn't be as packed. The houses would be more spread out. It would be less dense. And then if you were in the country, that would be even less densely populated with houses and people than this picture. And particles are a lot the same way. So you could picture these houses like particles, packed really tightly together, and then other particles are packed more loosely, like in the suburbs or in the country. Another property is malleability. These are materials that can be hammered easily into shapes or thin sheets. This is a common physical property of metals. And there's a picture of a blacksmith there who is hammering some metal into shape. Also, ductility. These are materials that can be drawn into long, thin wires. Again, a common property of metals. As you can see in the background here, I have some copper wire. There's also conductivity. This is the ability of a material to transfer heat or electricity between its particles. And in the picture above, or in the picture in the background, you can see wires, probably copper wires, carrying electricity through them. Now, if a material like copper is a good conductor of electricity, it's also a good conductor of heat generally. That's why we use metal pans a lot of times when we are cooking and baking. And just one thing to note is that copper is more conductive than aluminum. That is why we use it in copper wires because it is more conductive. That's why we coat pans. Maybe you have copper bottom pans. But aluminum pans are also very good conductors, but not quite as good as copper. Actually, silver is more conductive than both of them, but we don't use silver for electrical wires or for cooking very much because it's a lot more expensive than copper or aluminum. And a physical change is any changes in the appearance, shape, or state of matter in a material that does not cause a change in its chemical composition. So I have ice in the background. And the ice is undergoing a physical change to water. But when it does that, it's still water. So some examples are melting and evaporation. The same thing for water in a puddle. When it evaporates in the sun or when you boil it and there's evaporation, it does not, it's not a new substance. It's still water. You have not changed it at all. There are also chemical properties. This is a property that describes how matter acts in the presence of other materials or how it changes composition under certain conditions. One thing that we talk about with chemical properties is reactivity. This is the property of a substance that enables it to interact with another specific chemical. So when we talk about reactivity, we tend to talk about what does it react with, the substance, what does it react with, and how violently it reacts with it or how readily. Like, will it react with it instantly in an explosive manner? Or do we have to add heat for it to react? And is it a slow reaction instead of an explosive reaction? So reactivity is an important property. There's also flammability. This is the property of a substance that enables it to burn in the presence of oxygen. So is it flammable like this wood in the background? Is it flammable like magnesium tape? Will it burn? There's also toxicity. This is the property of a substance that makes it harmful for living organisms. So, poisons. Um, we have to be very careful with toxicity in the chemistry lab because we have to know the toxicity of the chemicals we start with and the chemicals that we end with because some things we can put down the sink and they'll be fine. Other things we have to dispose of in a proper manner because if we put it down the sink, it will get into our water systems and it's toxic to the organisms in our water systems. And if it gets into our water supply, it could be toxic to us as well. So, toxicity is an important thing to understand. Now, a chemical change is when a substance undergoes a change in which its chemical identity changes. So, in the background here, there's an iron lock and an iron hinge, and they started out as iron, but now they're rusting. They have iron oxide on them. So, that is a chemical change. Some examples are rust. When there is a gas produced, like in these test tubes in the background, when there's an explosion, also, whenever you have a color change, so probably some of these test tubes, you can see this one here has a color change in it, so there's a chemical reaction going on. Also, when a precipitate is formed, that's when you pour two liquids together and a solid is produced, and it looked kind of like there's a solid coming out here, and this is getting cloudy, so maybe there's a solid there. So precipitate formation also will indicate a chemical reaction, a chemical change, and a change in temperature. If something gets warmer when two substances are mixed or it gets colder, that is also evidence of a chemical change. So, our objectives today were to compare physical and chemical properties. So, the objectives for this video were to compare physical and chemical properties. And if you're still listening to this video, I want you next to reactivity to draw fireworks. Now, don't forget to also write your 5 questions in the margin for this video.